Throughout humankind's early history, the quest for greater knowledge and understanding fueled the need for exploration. For centuries, the vehicle most early explorers used to achieve this exploration was a ship with sails. But because these ships depended on wind pushing against the sails for forward motion, they were generally very slow, unpredictable, and often very dangerous. Today, with the multitude of ways that humans now possess to travel, the sail, with all of its limitations, has been relegated to recreational status rather than a serious tool for exploration.
But a new idea might change the way we think about sails. NASA researchers are actually developing a new type of sail that will use the sun's light to propel spacecraft deep into space. These solar sails are so promising that someday they may replace slower, more costly propulsion systems for deep space exploration. I spoke with Dr. Keith Belvin at NASA Langley Research Center to find out more.
Well, the idea for solar sails has been around for a very long time. Maxwell, back in 1873, predicted the existence of solar pressure lights. So we've known about solar pressure for a long time, but it wasn't until recently that we were able to build solar sails with the lightweight materials and structures that are needed.
Tell me about these lightweight materials and structures. How are they being used?
Well, the key to building a solar sail is, of course, to make it very large and very lightweight. For a useful solar sail, it has to have a weight of less than 10 grams per square meter. For example, copier paper has a weight of 70 grams per square meter. So we're talking about some materials that are much lighter than that. One of the things that NASA's done over the last decade is to work on materials that can be processed to just a couple microns. That's a couple millionths of a meter thick. And these lightweight, thin materials then are made space durable so they can withstand the radiation and temperatures of space.
Dr. Belvin, tell me how a solar sail works.
The basic principle is much like a ship on the sea that uses sails to capture the wind.
The sun is constantly emitting light, or photons, in all directions. Since the photons have mass and are in motion, their momentum produces a pressure when reflected by a surface. When a spacecraft uses a solar sail for propulsion, the sail's reflective surface transfers a continuous force from the photons to propel the craft through space, much like a sailing ship uses wind to push it across the water. Since the pressure being emitted from the photons is very low, the force is small. But because the sail will have a constant source of energy, it is continuously accelerating and can reach speeds upwards of 155,000 miles per hour. This speed could cut years off travel time during long-duration interstellar flights. In addition, the constant propulsive force provided by the sun's light allows the spacecraft to travel in orbits that are not affordable using conventional propulsion.
So can solar sails be used on all types of missions?
Well, in addition to solar sails having to be lightweight for various missions, the spacecraft they're propelling has to be very lightweight. But there are many missions where, with the miniaturization of electronics, that the spacecraft science sensors are very small and lightweight. And those systems are very amenable to being propelled by a solar sail. For example, we're looking at missions in the future where we do interstellar transfer of science instruments using solar sails.
So, do we see solar sails only being used in deep space?
Well, there are missions where solar sails can be used close to the Earth's orbit. They don't all have to be long-duration interstellar type missions. The constant acceleration that a solar sail produces gives it an orbit trajectory that is not achievable by some other means. For example, we can fly a science payload to measure the magnetic storms emanating from the sun.
How do you deploy such a large structure into space?
But to deploy a solar sail in space is quite a challenge. First of all, the sail has to be packaged in a small size to fit into the launch vehicles. Near-term sail missions are on the order of 70 meters to up to 150 meters in size. And so it's a real challenge to package those tightly and then deploy in space. Two aspects probably are most important for deploying a solar sail. The first is deploying the booms that hold the membranes in place. We're using inflation to push the booms out and to the right location, and then we cool the booms to rigidize them. The second aspect is deploying the sail, the thin film membranes that we've talked about. Those will incorporate ripstop so that if there's a small tear, it doesn't propagate very far. In addition, we have to deploy those so that we don't affect the sail's reflective performance. And so special measures are taken to maintain the integrity of that sail.
What is the future of this program?
I would say within the next dozen years or so, solar sails will be used routinely to propel spacecraft. Continual improvements in the sail technology will allow them to be used for extreme environments like near-sun missions. Over the next 20 years, most importantly, we'll have the technology in hand to do interstellar missions. These are kilometer-sized solar sails that weigh only 1 to 2 grams per square meter. The technology being developed today at NASA is going to enable us to unlock a lot of the secrets of the universe. Not only will we be able to look at distant places using telescopes, we'll actually be able to send science instruments to some of those locations using solar sails.
Did you know that the inspiration for solar sail technology came from the 17th century astronomer Johannes Kepler? Kepler deduced that winds blew objects around in space after he observed comet tails blown by what appeared to be a solar breeze. Kepler suggested that eventually ships might navigate through space using sails that could catch this wind.